Hey y'all, I hope y'all are doing great. I'm going to be talking to you guys about plate boundaries today and tectonic plates. In order to make sure that you guys are doing and getting this information, we would love for you to take notes. You can either have drawn them like you saw in the on the Canvas page like this. You could just have your own piece of paper and make your own notes if you want to be creative, or you could have printed this out if you would like. Okay, again, you don't have to print out, you can just do it on a piece of notebook paper. Let's get started. So what you're going to you need to answer today are the essential questions. Just what are plate tectonics? What are the three different types of boundaries? And what are the crustal features that are formed at these boundaries? So before we begin, we need to circle back to a little bit of earth layers and thermal energy. And if we remember, the lithosphere or the crust, the outermost layer of the earth is broken up into what we call tectonic plates. And these plates will move and shift throughout time, and we need to know why and how they shift. So they shift because of the asthenosphere. So the asthenosphere has convection currents, and we learned that in thermal energy. That in convection currents, the hot fluid will rise and the cold fluid will sink. And that's no different in the asthenosphere. The hot magma will rise and the cold magma will sink. And when it does this, it actually moves the plates, the tectonic plates, different ways. And that is where we get the movement and all the landforms created and all these plate boundaries, is when they start to move in these different directions. So let's learn about those different plate boundaries. But before we do, we need to look at the different types of crust. So the crust is broken up into two different types. So there's what we call oceanic crust and continental crust. Continental crust is what forms our continents. This is going to be older than oceanic crust, and it's mostly going to be made out of granite rock. It also is thicker, however, it is less dense than oceanic crust. Oceanic crust is a thin layer of crust that underlies the ocean basins. It's younger, however, it's going to be more dense. So if you were to have these two crusts that were ever to, like, let's say they were to come together, at any point, the oceanic crust would actually fall below the continental crust because it is more dense. Okay, so remember that. What happens at plate boundaries? So plate boundaries are when two major plates, or even some of the minor plates, they meet. And when they meet, they're either going to do one of three things: move apart, come together, or slide past each other. When they collide, that is considered a convergent plate boundary. When they divide or move apart from each other, that is a divergent plate boundary. And when they slide past each other, that is a transform plate boundary. Now, a convergent plate boundary, when they collide together, that is going to destroy crust. When they move apart from each other, so think about if two plates were to move past each other, then there's nothing there yet. So what magma is going to come in and fill that in, and then it's going to harden, it's going to create crust. And then we have transform plates, plate boundary, in which the two crusts will either destroy or create. They're just going to slide past each other. So let's first look at the divergent plate boundaries. So when you have two plates that are dividing or moving apart, they can be continental or oceanic crust dividing. They are going to create crust. So when two oceanic crusts diverge, they create what we call a mid-ocean ridge. And we see that we have a huge one on Earth, and it's in the Atlantic Ocean. It's called the Mid-Atlantic Ridge. And this is where we have two major plates moving apart from each other, and then it's being filled in by magma, and it's going to harden. So that's what we call a Mid-Atlantic Ridge. The other type of divergent plate boundary is when we have two continental crusts. So if we have two continental crusts, we're going to form what we call a rift valley. So if you look over here, this is what a rift valley is. Okay. This is when the new crust is created, but it's on continental crust. And a perfect example of this is the Great Rift Valley in Africa. As you're doing this, if you want to pause and go look up what these look like in real life, that would be awesome, because that way you can actually get a really good visual of what these features really look like. So the next one is going to be our transform plate boundary. This is when plates will slide past each other. When plates actually slide past each other, they're going to create what we call a fault line. And this is where we're going to get a lot of earthquakes. So if you think about it, what happens is if you think about a rubber band as well, like if we were to keep moving them farther and farther apart, they're basically creating so much tension that at some point that tension has to break. And when it does that, it snaps kind of, and then it starts to create an earthquake. And we see a major one in California. It's called the San Andreas Fault. And if you notice how big it is, it's huge. And that's what's going to create a lot of this boundary is going to be causes a lot of the earthquakes that are in California. The next one is going to be the convergent plate boundary. Now there's multiple different types, so hang in there as we learn about them. The main thing you do need to know about this though is that convergent is just when they collide. So when two plates collide, they're going to form different types of landforms. When you have two continental crests, so that land, and they come together, they're going to create what we call folded mountains. So they're just going to create those mountains like the Himalayas. Continental and oceanic crests, if they were to come, you're going to have that oceanic crest that's more dense. It's going to come underneath the continental crest. And when it does that, it kind of lets this little spot open, and you get volcanoes that are forming there. And then oceanic and oceanic, you're going to have both, and at some point one's going to fall underneath the other, and it's going to actually create volcanic arc of islands, such as the Aleutian Islands in Alaska. So on a continental, this is when two continental crests collide and push against each other. Wow, I can't talk right now, guys. This pressure causes both plates to rise, creating folded mountains. So you'll see here, this is kind of what you see, these two plates that come up together. An example of this would be the Himalaya Mountains. The next one is going to be if oceanic and oceanic were coming together. They would collide and push against each other. The older crust, so whichever one is the older one, is going to go below the other one, which is what we call subduction. So it will subduct. And this is going to create the volcanic arc of islands. So if you notice all right here, these are all the islands it's created. So as it did it, it creates these and it keeps moving. And right here is where that layer, that older layer starts to subduct below the other one. And when it does that, it causes the magma to be able to come out and create this volcano. So the last type of convergent boundary is the continental oceanic boundary. This is when the ocean crust is going to, because it's less dense, is going to go below the continental crust or subducts, and because it's more dense. This is when volcanoes form on the actual continent themselves. So when the continental crust goes up, the oceanic crust goes out, and so then you're going to get the volcanoes that form right here. So this is the subduction zone is what we call. And when this happens, we get what we call a trench that is formed here. So you'll get volcanoes and you'll get trenches. One of the most famous boundaries and the landforms that are created is the Cascade range of volcanoes, which is all right here. Oops. And again, the old crust is destroyed and it creates these new volcanic arcs. So that are on actual land, not in the ocean. So that's the end of all of these different ones. If you needed to pause, go back, rewind, go ahead and do so. Here is what you should have written down. I will also post it on the Canvas page for you to look at in the end. Let me see if I can move that down. There you go. So you can see all of it. So I hope you guys understand this. Please feel free to email us or to drop something in the discussion board if you're not understanding something. We'll try to answer it the best we can. I hope you guys are good. Have a good rest of your day. Bye.